Hello and welcome to my channel. I am Mensa Augustine. Thanks to Reverend Calvin Samuel Donko and Benjamin Bafo Ewa for supporting my channel. The donation is still ongoing. If you want to support my channel, this is my mobile money number. The name on it is Mensa Augustine. Still, it has left with 960 Ghana cedis, which is equivalent to $169. We were looking for 1,200 Ghana cedis. We want to buy a microphone and a camera to produce quality videos. So kindly send any small amount through my mobile money number, or if you have the microphone, if you have some of the microphone or a camera that you want to give it to me, you can call my number and you'll see how it will reach me. Thank you for supporting my channel, and I hope you will donate. Now, in this lesson, we'll be looking at the short way to differentiate using the chain rule, shortcut method for differentiation using the chain rule. Now, we will take this. Let's see this. If I have y equal to 5x squared plus 7 to the power, let's say 8. How do you differentiate this? Here, we are going to use shortcuts. So this is what we do. You bring the 8 in front. So the derivative of y with respect to x is equal to, you bring the 8 in front, times, you differentiate this one. If you differentiate 5x squared, you get 10x times the original expression inside the bracket. So that is 5x squared plus 7. Then subtract 1 from this. So you are going to get 80x 5x squared plus 7 to the power 7. Very simple as that. Let's see this one. If I have y equal to, let's say, cube root of 7x squared minus 5x plus 8. You know that this is the same as 7x squared minus 5x plus 8 all to the power 1 out of 3. So what do? You bring the 1 out of 3 here, times, then differentiate what is inside. So this one gives us 14x squared, this one gives us minus 5, this one will be 0. So you put this in brackets, times the original function inside. So 7x squared minus 5x plus 8. Then you subtract 1 from the power to get negative 2 on 3. So this will give us 14x squared minus 5 on 3 times 7x squared, 14x minus 5x plus 8 all to the power negative 2 out of 3. We are not interested in the simplification now. What we are interested in is the shortcut. So that is the shortcut. If you don't want to say let this, if you have your section A and you have this question and you want to solve it, very simple. You can even do it in your head. Nice, right? And let's take our 2 or 3 more examples. Somebody there watching is thinking about this. If I have y is equal to sine to the power 7x squared minus 3x plus 9. So here what do? You bring the power 7 in front. Then you write, we differentiate the inner one. So that will give us 2x minus 3. Times, what do? What we are going to do here is that you will see that this one has been differentiated. Look at this. This is sine x squared minus 3x plus 9 all to the power 7. Wow. So here what we are going to do is that The inner functions are two. We have sine and we have this. So we have differentiated this. So it has left with us differentiating the sine. So if we differentiate the sine here, we are going to get cosine. And it is cosine what? Cosine of the angle. So the angle is x squared minus 3x plus 9 times the original function inside. So this is the original function inside. Sine x squared minus 3x plus 9. Then we take 1 from the power. So we write power 6. Wow. Very simple as that. So if you want to simplify it further, you multiply 2 by 7, you have 14x minus 21 times cosine x squared minus 3x plus 9 sine to the power 6 x squared minus 3x plus 9. If you have not watched my video on how to use chain rule to differentiate trigonometric functions, you watch the video, it will also improve your understanding here. But here we are just looking at the shortcut. Very simple. So you see this is the same as sine x squared minus 3x plus 9 all to the power 7. So what do? We have two inner functions. So you differentiate this one. You get cosine. But cosine of what? Cosine of the angle. So you bring the angle. Then you differentiate this one too. This one too is inside. So you will get 2x minus 3. Then we are finished with that. Then this power will come. So we bring the power in front. Times the original. And this is the original. Sine into bracket x squared minus 3x plus 9. Then we take 1 from the 7. So it will become 6. Or you can write it as this before you bring it to this part. But the same thing. Wow. Or you can do that in your head and it will help. Now let's see. So if I have, let's say tangent or cotangent, let me take cotangent, cosec rather, sec. If I have y equal to secant to the power 5 into bracket 3x cubed minus 2x squared minus x plus 5. Let's do this in our head. So first, what do? The 5 will come. This one is inner function. So we take 3x cubed, we differentiate to get 9x squared minus 4x minus 1. We have to differentiate secant too. If we differentiate secant, you get what? Secant and then tangent. You get secant of the angle times tangent of the angle. And this is the angle. So we write secant of the angle 3x cubed minus 2x squared minus x plus 5. Then tangent of the angle times tangent of 3x cubed minus 2x squared minus x plus 5. Wow. So if differentiate the inner function, I differentiate the secant too. Now what is left? We are going to write the original function and subtract 1 from the power. So let's write that one here. So we are going to have the derivative of y with respect to x is equal to 5 times 9x squared minus 4x minus 1 times secant 3x cubed minus 2x squared minus x plus 5 times tangent, times tangent 3x cubed minus 2x squared minus x plus 5 times the original. So the original is what? Secant, let me bring it here, times secant, then subtract 1 from the power, so power 4, 3x keep minus 2x squared minus x plus 5. Wow! So now if you reach here, you see that we have secant power 4, and the angle here is the same angle that we have here. So you multiply them together. So secant power 4 times secant power 1 will give us secant power 5. So if you multiply through by 9, here we are going to have 45x squared minus 20x minus 5. Then we have secant to the power 5, 3x cubed minus 2x squared minus x plus 5. Then times tangent, 3x cubed minus 2x minus x plus 5. Today we are interested in the shortcuts. So that is the shortcut. Very simple. So what will be the shortcut? Bring the 5 here. Differentiate the inner function. Then differentiate the secant itself. Because this one can be written as secant into bracket 3x cubed minus 2x squared minus x plus 5. All to the power 5. You see that? So secant is a function inside this, and this one also is a function inside the secant. So you differentiate the secant, you get secant of the angle, tangent of the angle. That is what we have there. Then if you differentiate the inner function, you are going to get this one. Very simple as that. Then you multiply it by the original function, but you subtract 1 from the power. Very simple as that. So if you have trigonometric functions too, that is the simplest way that you can use the chain rule in session A or mentally. Let's go with that. So watch my video on differentiation of using the chain rule to differentiate trigonometric functions. It is in the description. Okay, let's take the last one. And this will be the last one. I hope you've seen the trick. So let's take this. For example, I have y is equal to cosecant 5x. This one, the power is what? Power 1. So there's no need doing anything. So what do we do? What we are going to do is very simple. You differentiate this one. So you get 5 times, you differentiate the cosecant. So what do we get? We are going to have negative cosecant of the angle, then cotangent of the angle. That is 5x. Very simple. So we are going to have minus 5 cosecant of the angle times cotangent of the angle. Oh. And we are done. Very simple as that. Here the power is 1. We have power 1 here. We have power 1. So since the power is 1, if we bring 1 in front, 1 times 5 will give us 5. And if we differentiate the original function, we are going to get cosecant 5x, cotangent 5x. If like, let's see, if you let u to be equal to 5x, you see that dy on du will be equal to 5. And this implies that y is equal to cosecant u. And what is cosecant u? dy on du will be equal to minus cosecant u cotangent u, and that will give us minus cosecant 5x cotangent 5x, and dy on dx will be equal to dy du. Oh, sorry, this is dy dx. That is dy dx. Du dy dx. Oh, that is du dx is 5. And dy du is minus cosecant 5x cotangent 5x. So dy dx will be du dx, that is 5, times dy du, and this is what we have. Minus cosecant 5x cotangent 5x, and that is what we've done it here already. So that is the short way, that's the shortcut way of differentiating using the chain rule or the function of the function rule or the composite function rule. Thank you for watching. Bye bye.